Hello and welcome to Learning Space. Today's episode was a little bit delayed due to a tech stupid on my part. I accidentally had my settings set for a training session I did earlier today. I appreciate all your patience for the lack of me being here on time.
I'll just say we did a pretty good show already, so anything you're getting now is just gravy.
It's true. We kind of rocked those first 12 minutes. So with me tonight, as you've heard, is guest Morgan Rehnberg, who is at the Fort Worth Museum of Science and History. You want to tell us a little bit about yourself, Morgan?
Yeah, it's great to be here. My training as a scientist is in astronomy and planetary science. But along the way in my career in science, I started realizing that I liked kind of talking about science more than I liked doing science, or at least doing research. And I think that's not an uncommon realization for people in our line of work. And that started me off on a journey to try to kind of figure out how I could go from where I was to doing more of that talking and less of that banging my head against my computer. And through a series of sort of unexpected turns, I found myself at the Fort Worth Museum of Science and History, where I work as the museum's director of scientific presentation. And that means that I get to spend my days looking at the amazing assets that we have within the museum and trying to figure out how to best leverage them to communicate what scientists do and what we're learning about the world in the past as well as right now today. And it's a lot of fun.
That is kind of awesome. And part of what both of us get to do with our jobs is share with the world what is going on with the universe. And one of the things we like to do at the beginning of each Learning Space episode is do a quick rundown of the news for everyone who's currently missing the daily space. So I see that we were just joined from Sydney. Welcome. It is almost lunchtime where you are. So this Learning Space series, we alternate each week, whether we're early in the day or late in the day, so that we can start to pick up the Pacific Rim, essentially. Now, for those of you who haven't been able to keep up with the news, it's been a kind of amazing week. And here I am going to just me and our news slides, and I'm going to come back to that. So it's been a wild week in the news. With the American Astronomical Society meeting taking place, we have had every possible kind of science discussed. We started out with discoveries. Well, we didn't start out. One of the places that we landed was discovering through computer models done in large part by students working in South Africa that it turns out triple body systems with 3 stars are perfectly capable of housing planets. Now, to make that even more interesting and tantalizing, Chandra released an update today that the nearest triple system, in fact, the nearest star system of all, the Alpha Centauri system, isn't particularly active with X-rays. This means we can go ahead and send robots, and those robots are going to be just fine. Now, in addition to studying stars, in addition to studying those types of stars, we've also been studying what are called population 3 stars. These are stars that have the fewest heavy atoms by percentage of all the stars out there. We talk about this as low metallicity because if you're an astronomer, there's 3 elements: hydrogen, helium, and everything else. And in these stars, everything else kind of doesn't want to be seen. These are the stars that existed after the first generation of the largest and fastest dying stars. Well, they formed, they lived, they died, all before the smaller stars were done coming into existence. As we study them, we're finding that, well, they are deep within our Milky Way. They're getting found in the disk of our galaxy. We also have scientists that have been presenting models on how these initial stars formed out of gas and dust, and how these initial clouds of small irregular systems were able to form together to form the galaxy we see today. Now, we've also seen a variety of different results coming to us concerning globular clusters. We have both determined these systems absolutely positively do not have, as near as we can tell, which means we may be proven wrong later, they do not seem to have intermediate mass black holes. In addition to that, we've learned they're about 4 billion years younger than we thought. This tells us, our ideas of exactly how the galaxy formed aren't entirely right, because we thought these systems were older than they are. We've seen other studies on the merging of systems where we've learned things as wild and awesome as when two small systems that are the same size collide, both black holes get to eat something and become alive as active galactic nuclei. But when two systems of very different sizes merge, only one of those two black holes gets to feed, and we come up with a single active galactic nuclei. Now, in today's big news, which many of you may be seeing getting talked about, we had two discoveries coming to us from NASA about Mars. The first was, it was adding sigma to a discovery we'd already made, which is the methane on Mars appears to be seasonal. We'd had hints of this in the past, but with this year's data from Mars, we were finally able to say, yes, with certainty, at least where Mars rover is located. We get methane when it's warm, and we get no methane when it's cold. Now, this doesn't tell us there is life. What it tells us is the methane is not coming from some sort of a tectonic or volcanic process. It is either coming from melting ices that have methane trapped within them, or it is coming from life. But we don't know. We don't know. When we know, I promise you, we'll be here to tell you. Now, those were all the stories I thought to bring up, but in our first time through taking care of this story, Morgan brought up that I was missing his favorite story. So I now have that and Morgan up on the screen. So do you want to tell us a little bit about those dunes on Pluto?
Yeah, these sand dunes, and by sand I mean little tiny bits of methane that were discovered on Pluto and reported in research this week, were my story of the week. Because sand dunes are these sort of magical things, and they only form under sort of weirdly specific conditions. Combinations of things like the size of the sand particles, the density of the sand particles, the stickiness of the sand particles, the strength of the gravity at the surface of that planet. And so the mere observation of sand dunes suddenly collapses down all the possibilities of what that surface might be like into a much, much smaller range of possibilities. And so to see sand dunes on Pluto is just amazing that we can see these sand dunes. And if you're thinking about where they are, if you think of the heart of Pluto, they're kind of right on the edge between the plane, the heart, and the mountains. The plane is made of nitrogen, and the mountains are made of water, or water ice. And just like here on Earth, the sand dunes pile up against the mountains. That makes a lot of sense. But the way in which those sand dunes came about is probably totally different than the sand dunes here on Earth.
Now, one thing that you said that caught my attention was this could only happen on Pluto. And we've seen big cracked icy surfaces on worlds like Europa. Why can't we get this on icy moons?
The key to sand dunes is wind, because otherwise you just have scattered sand. You need the wind to pick up that sand and move it somewhere where it basically collects and piles up. And so on a moon like Europa or Enceladus, there's no atmosphere. And if there's no atmosphere, there can't be any wind. But what it turns out to happen on Pluto that's so interesting is that having wind isn't enough. On Earth, having wind is plenty. You blow some wind and it kind of picks these sand particles up and they form these sort of like half circles as they bounce along the surface until they catch into an enclosure that kind of piles them up. But Pluto's atmosphere is so thin and its winds are so slow that they lack the force necessary to kind of overcome static friction and break those sand particles free. Once you get them levitated, the wind is plenty strong enough to move them around, but getting them off the ground is basically impossible for the wind. And so what this modeling result, this paper was designed around, shows is that something that's pretty unique to Pluto, which is that basically its whole surface sublimates off and then collapses back down as it goes through temperature variations. That the nitrogen sublimating off the surface actually will pick those particles up and jar them loose enough that wind can then move them around and pile them up in those dunes. And so we're seeing bits of nitrogen or methane that probably condensed down on that big icy plain. And then as that nitrogen sublimates off, it lifts them up and wind catches them and blows them against the edges of the mountains. And these mountains are the size of the Rocky Mountains here on Earth, but made of ice instead of rock. And it piles them up just like Great Sand Dunes National Park here in the United States piles up these tremendous, astonishing sand dunes up against the westward side of the Rocky Mountains.
Now, our audience can probably tell you have just a wee bit of experience communicating the news and a small amount of knowledge about planetary science. So can you, as a starting point, tell everyone what exactly was it that you studied while you were getting your PhD up in Colorado?
Yeah, when I was in Colorado, and actually dating all the way back to my years as an undergraduate, I worked as part of NASA's Cassini mission to Saturn. And technically, I'm a planetary scientist, but I actually really didn't study planets at all. And so I'm always sort of talking not from a place of experience when I talk about planets proper, like hard, rocky surfaces. Because what I studied were the rings of Saturn. And the rings of Saturn are an incredible, unique natural laboratory in the solar system where we can test physical ideas out that apply all over the universe. Because the rings are this incredibly thin disk. And it turns out that disks are really, really common throughout the universe. Second to spheres, disks are what's out there. Our galaxy is a disk. Our planets all orbit in the same plane because they formed out of a disk. The moons of planets like Jupiter and Saturn all orbit in mostly the same plane because they formed out of a disk. If you're not going to end up in a sphere, you're going to end up in a disk. And so now that we're finding all these exoplanets out there in the galaxy, we're starting to question how planets get from those disks into the solid objects that we observe all over the galaxy. But those disks are impossibly far away for us to ever go and study. And they're impossibly far away for us even to be able to go and resolve what's happening on a fine scale. But the rings of Saturn are an astrophysical disk that have some of, but not all, the same properties as protoplanetary disks where planets form. And for 13 years, from 2004 through September 2017, NASA's Cassini spacecraft was constantly orbiting Saturn outside the rings. And so we had this incredible sort of high-definition view of a disk of particles that we could study to understand what physics happens in particle disks that we can hopefully then apply to the formation of planets or even the formation of galaxies. Because if you've ever seen a picture of Saturn, you probably think of all those kind of circular striations. Kind of looks like a record. Those striations are caused by the same physics that gives spiral galaxies their arms. It's the exact same physical property called a spiral density wave. And it just happens that they work at a different scale for galaxies than they do for planets. But we can use the physics we understand in one place to understand what's going on in a whole different scale. That's the beauty of physics. And so what I did was study the rings of Saturn at the smallest possible scale. And I did that using a technique that is like almost stupidly simple. And it's called stellar occultation. Basically, Cassini had a very sensitive light sensor mounted on its side, and we would point that light sensor at stars in the background. And we would make brightness measurements of those stars up to 1,000 times a second. And then we would watch those stars pass behind the rings. And you can imagine that the more stuff between your light source and your camera, the dimmer your light source is going to appear. And so as that star passed behind the rings, we measured its brightness changing and interpreted that as more or less stuff between the star and the spacecraft. And so by watching that star pass behind, we were basically able to make an incredibly accurate density profile of Saturn's rings with just one problem, and that's that it was in one dimension. So rather than getting a picture in 2 dimensions, we basically got a razor-thin slice across the rings. And you might say, that's not really that useful seeming. And for some things, it definitely isn't. But the benefit that we get through losing that second dimension is an astonishing increase in resolution. Up until the last few weeks of the mission, the best Cassini images were resolving the rings at a resolution of something like 1 kilometer per pixel. That's basically the city block scale. So imagine flying your spacecraft over New York or London or Shanghai, and you get 1 pixel for every city block. You know, you can discern some basic patterns, probably like where the streets are and where Central Park is, but you're not going to understand what's happening at street level. You're not going to understand the character of the city. But with stellar occultations, we weren't studying them at 1 kilometer per pixel. We could study the rings at 1 meter per pixel. And so as part of my work on Cassini, I could find sort of things like the desk you have at work orbiting in the rings of Saturn from 1 million kilometers away. And if you look at the rings this closely, what I discovered was they look incredibly ratty. If you have like an Afghan at home and it's got those holes in it and it's got the threads running through it, that's what the rings of Saturn look like. There's areas where it's really dense and then areas where it's completely empty. And it's only if you hold that Afghan really far away does it look like one big continuous sheet. And that's what we see when we take pictures of the rings of Saturn.
Now, this is just super cool stuff, and I brought up a occultation graph, and then brought up one of the images of Saturn being illuminated from the side and seeing the shadows of one ring against another ring. This is the kind of thing that we just don't have super detailed. Let's take a picture of all of these rocks. I can't tell you one is shaped like a potato and another like an iceberg. But the detailed measurements. This was actually one of the first stories we covered back with Slacker Astronomy in 2005 or 6, was how this work was starting to take place. And
it's incredible what Cassini was able to discover. The returns on that mission so far outstripped what even the most optimistic team members imagined. And even, the last days and weeks of the mission, we were finding things like those ravioli-shaped moons. We'd spent 13 years looking at those moons because they're embedded in the rings of Saturn and assuming various things about them and how they interacted with the ring material around them. I'm not aware of anyone who ever proposed that they would look like ravioli. Every conceivable thought about them had been aired and suggested, but the idea that they looked like ravioli was inconceivable. And so, 13 years minus 1 day on in the mission, we were still discovering just absolutely incredible, jaw-dropping things about Saturn that we're now going to need the next 13 or 15 years to disentangle and try to understand the implications of everything that Cassini was able to observe.
And what I really love is just by feeding theorists the fact that there are multiple ravioli-ish shaped moons. Some look like how I make ravioli instead of how my grandma made ravioli. They've been able to figure out ways to model this kind of formation. So it's not lack of ability that led us to not predict this. It's lack of imagination, because the actual universe is far crazier and more awesome than what we keep bothering to theorize.
Yeah, that's the advantage of being an observer and not a theorist, is things are always more surprising and more imaginative and more amazing than you could ever cook up on a piece of paper. Now, they're also a lot messier than the world of theory, and that leads us to see all these sorts of seemingly unexplainable things that we then need to run back to the theorists and say, help, help, please save us. We don't know what's going on. And given enough coffee, eventually a workable theory emerges, and that's what lays the groundwork for figuring out, okay, we're going to go back to Saturn in 15 or 20 years. What do we want to look at next time that's going to seriously challenge the thoughts that we have today?
Now, you went from working on one of the most amazing spacecraft we've had in a long time to doing something radically different. And let's face it, you probably could have spent the entirety of your career working on Saturn's rings, which is both awesome and terribly depressing all at the same time. What was it that got you to make this transition from regular everyday graduate student to graduate student hosting one of the coolest astronomy news podcasts out there?
Well, I promised myself when I entered graduate school that I was going to sort of explore every alley and imagine every potential future for myself. And the reality is I didn't do that. But I did explore some alleys and imagine some potential futures. And one of those was communicating science. And honestly, in some ways, it was a little self-serving to start with, because I realized as I started my work, even the summer before I officially entered graduate school, how easy it was to sort of get sucked down into your one little specialty. And I can, describe for you as well as anybody how a stellar occultation works. But honestly, it's not that interesting after a little while. And I told myself that I needed something that was going to ensure that I broadened out a little bit and at least knew stuff that was happening elsewhere in astronomy. And honestly, and I couldn't tell you sort of what led me down this direction. That's what ended up connecting you and me, because my solution to that yawning problem was to start an astronomy news podcast that would force me once a month to at least Google astronomy and click on Google News and see what the heck was happening in the rest of the world. And I contributed those podcast episodes to the 365 Days of Astronomy podcast. And, I think this would have been 2012. And so it was already, 365 was already several years running at that point. And I started making these podcast episodes, and they were truly terrible. And I think, thankfully, I'm not sure that any of the original ones still survive, although I guess they're probably in your archive somewhere.
Yes.
But they're not on my computer, which is a very valuable thing to me. And after a few months of doing that, I started a blog called Cosmic Chatter, and I wrote a lot. I started off sort of promising myself that I would write something every day, and I didn't stick to that. But I probably wrote 3 or 4 or 5 things a week. And in the first year, I wrote hundreds of little news bites about things that were happening that then fed into my podcast. And then when it came time to renew the podcast, uh, which of course I was doing for nothing because that's what we all do, I used what little leverage I had and said, hey, if you want me to do this podcast again, I want to get to come on the Weekly Space Hangout once. And surprising to myself, you said yes.
Of course I
did. And I appeared, and my very first episode was probably my most memorable one ever. I went on with some story about Mars science and talked about how the astronomy and planetary science community views Mars, which is not always in the most favorable light. And I was doing this podcast the same day that Casey Dreyer from the Planetary Society was on there. And not 3 minutes after the show had ended, I had like a 5-paragraph email from Casey sitting in my inbox breaking down why I shouldn't criticize in the absolute nicest and most correct way, why I shouldn't criticize Mars exploration in public, basically. And that was a real sort of wake-up call to me, but it hooked me. And I showed up the next week, sort of unbidden, and 4 years later, they haven't been able to get rid of me.
Well, and more to the point, you are now one of the primary hosts.
Yeah, and last summer, after years of it, Fraser Cain and I sat down and said, okay, this really isn't working anymore. And we kind of complained at each other over the summer for a while and said, okay, well, what can we do to fix it? And both of us were, or continue to be, big fans of some of the podcasts from the Slate family and decided, okay, that's what we want to do. And so we recruited a couple of the more reliable and more amazing of our collaborators, Kimberly Cartier from the American Geophysical Union and Paul Sutter of Ohio State.
The Ohio State.
The Ohio State University to join us on a rolling weekly basis. And we're about to finish up the first full season of that, and I think it's been a great success. Our stress levels have gone down. Our success and productivity has gone up, and we're still having fun, and that's the most important part. And so that's like one tiny little branch on the tree that got me from first-year graduate student to where I am now.
And in a lot of ways, I think many of us owe our careers to sitting still too long within the sights of Fraser Cain. We've all gotten sucked in different ways, and quite often we initiated first contact. I was doing Slacker Astronomy back in 2005, 2006, and we decided to start up the Council of Doom and invited Fraser, who was one of the few voices out there.
Names were much cooler back then than they are now.
Well, there were more URLs available back then. And so we invited Fraser to join our Council of Doom. And when I moved and started working at a public university where it probably wasn't a good idea to have a podcast rated for mature audiences, I joined forces with Fraser, and ever since I've been getting dragged into things. And it sounds like you're having this exact same experience. But like me, you also have a day job that lets you communicate science as well. Just to catch everyone up who's joining us, this is Learning Space. We are part of CosmoQuest, which is a multi-institutional collaboration led out of the Astronomical Society of the Pacific, where I'm the Director of Technology and Citizen Science. We are a 501c3, so all of your subscriptions and all of your bits really matter. Now, I'm not the only one here who's doing nonprofit science and science communications. Tell us a little bit about your day job, and we know this is off the record, you talking as you.
Yeah, I work at the Fort Worth Museum of Science and History in beautiful Fort Worth, Texas. And as an aside, I'll say I didn't grow up in Texas. I grew up in Pennsylvania. I went to school in Wisconsin. I went to graduate school in Colorado. I don't think I ever imagined myself moving to Texas. And the day that I sat my girlfriend down and said, I got a job, was one of the more unique days in my life thus far. But it's turned out to be wonderful.
Now,
I
have you gone to the Fort Worth Livestock Show and Rodeo yet?
I have indeed. I haven't been to the rodeo, but I've been to the stock show, and it's a sight to behold. In fact, our museum is on the grounds of the stock show, and so if you happen to come to Fort Worth to visit the stock show, which is something that many people do, you can gain admittance to the museum for free for the duration of the stock show, and we get a truly different cross-section of the population during the month of February when the stock show is happening than we do the rest of the year. We also get to wear blue jeans to work, which is its own special, and cowboy boots, but I don't have cowboy boots. So I haven't gone full Texan yet. But my job at the museum is kind of nebulous. I'm in this department called the Academy of Digital Learning, which is charged with looking across the whole museum and identifying ways that we can take technology and use it to foster social learning. So we don't want technology just sort of to show itself off for technology's sake. And we don't want technology just to make our lives easier because we don't have to fabricate new exhibits every time we want to do something. We want technology to be the way in which you interact with those around you. Because I think we all know somebody like under the age of 10, and they assume, and not unreasonably, that any computer screen that they approach, no matter how big or small, is a touchscreen. And if they walk up to a screen in our museum and touch it and nothing happens, they're put off and discouraged. And it's a sign that our institution isn't achieving their attention because we're not addressing them in the ways they're used to interacting with the world. And so in recognition of that, the Academy of Digital Learning looks at sort of what the world of technology is going to look like 5 years from now or 10 years from now, and works to figure out how can we make that happen today, because some parts of nonprofits are always behind the times. And so if we can get ahead, then when we're behind, we're actually right where we need to be, which is engaging with people the way they want to engage, because that's when the learning really happens. And that's how you build sort of a lifelong partnership between an individual and the scientific community. If science seems disconnected from their lives, either because scientists don't look like them, or scientists aren't talking like them, or scientists aren't talking to them in the way their friends talk to them, then it's almost like we're a separate entity, a separate standoffish organization. And that's the last thing that we can have if we want to successfully communicate the amazing endeavor of science to the broader world.
Now, the touchscreen thing reminds me of at South by Southwest several years ago. I was working in the NASA pavilion, and just like you said, kids come in and they're like pawing the monitors and getting really confused when the monitors don't respond. Now, while the children were confused that the monitors didn't respond, the monitor snob inside me was going, oh my God, they have ice cream covered sticky nasty germy fingers. The plague vectors are touching the monitors. How do you handle the fact that touch screens are vectors for the plague?
Well, thankfully, that's not my job, number one. But it's a good example of how changing your medium of communication, changing your technology, has to change how you behave sort of operationally. So we have hand sanitizer out the wazoo at the entrance of every gallery. And we have people who have to go around and sort of clean touchscreens. We also don't allow ice cream in our galleries, and that is a step up, I guess, from South by Southwest. But it's a real problem. And when you encourage people to touch, you also encourage them to touch hard and ultimately break your things. And so that forces you to think out of the box in ways you can create these engaging interactive experiences that are a little hardier. And so, for example, I have had the chance to see some really interesting up-and-coming technology that basically puts touchscreens on anything by combining a projector with computer vision.
Yeah.
And so you do a really short throw projector so you're not casting shadows on it. And you have a camera that is figuring out where you're touching. And then you can project on a piece of glass or a plain blank wall or something infinitely cheaper and more replaceable than a fancy IR touchscreen. And so you can put all that fancy stuff up in the ceiling where your little kid is less likely, but never impossible to get to. And maybe that forces you to create an interesting exhibit that works around that technology. And so it's always a process of learning what's coming and learning how people are engaging with what we already have to try to figure out what to do next. And so this is the excuse that I use for about 4 times a day when I get up and I walk all through the museum and just kind of watch people do things. Because I want to get a sense of how are they interacting with what we have and what can we do to reward the interactions that they're doing and lead them in the direction of the interactions that we want them to do. Those aren't necessarily the same thing.
That's true, and Uncle Bill is pointing out in the chat, never underestimate the power of kids. This is something that I've underestimated much to my regret more than once. And you're right. It is this multi-sided issue of trying to figure out how to develop content that first gets people to move through the exhibit so that they're getting the story in the correct order, not learning the punchline before they learn the background, and also making sure that your exhibit lasts more than 1 day, 1 week, 1 month, because money is limited. Now, as you're looking to the future, what technologies are you most excited to see starting to come into reality?
I think that the technology that people across the museum world are probably most excited about is augmented reality. And this is future augmented reality, not hold up your phone augmented reality, although that's a stepping stone that we're exploring. The future of 5 or 10 years from now, when we all have the ability, if not the daily necessity, to put on a pair of lightweight glasses that project virtual objects into the physical world, has just tremendous opportunity, both as a teaching tool and as an equity tool.
Yes.
From the teaching perspective, as we walk through, say, a dinosaur gallery, you could imagine looking at a dinosaur and then overlaying what we think its skin might have looked like right on top of those bones, or putting a virtual dinosaur next to that bones, that skeletal dinosaur, to see, okay, what would this dinosaur look like next to T-Rex or next to Stegosaurus? There's also the opportunity to shape the information presented to the guest based on their interests. So maybe you enter our museum and we ask you a few questions. How old are you? What are you excited about? How many people are you with? Or something like that. Maybe you say, I'm a 10-year-old who loves aviation. Or maybe you're a 45-year-old who loves history. You could both be walking through the same dinosaur gallery, and one of you might be seeing how do we think dinosaurs evolved into birds. There's your aviation connection. And the other could be seeing, okay, well, what tools do paleontologists use to excavate bones? Where do we think these bones came from? What do they tell us about the drifting continental plates over the last 100 million years? Same physical space, same real objects, two totally different experiences. And then you can take that one step farther and layer things in like different languages.
Yes.
So maybe you're coming in and you're a native Japanese speaker. Or here in Fort Worth, we have a large Vietnamese population. We localize a lot of our content in the museum in English and in Spanish, but we don't localize anything in Vietnamese. But with this technology, everything could just natively be in your language. Or maybe, the sort of companion technology to AR is VR. And VR offers maybe an even more immersive experience with some limitations in terms of you sort of stuck in your one little space, you can't see the real world. But for some guests, those limitations might be advantages. Imagine you're somebody on the autism spectrum, and our museum full of little kids running around screaming is kind of an off-putting, maybe even disorienting experience. What if you could go through the whole museum from the comfort of your school or your home? Now we're opening up the museum to categories of visitors that otherwise have never had the opportunity to come in and engage with what we have. And if we truly believe that what we're offering in the museum is important and valuable to society, then it should be important enough to offer to everyone. And right now, that's a challenging thing to do, despite what our best intentions might be. But VR or AR might mean that the very things we're building for most of our guests are the things that work for all of our guests. And that, in my mind, is the sort of holy grail of using this social technology.
And it is really powerful. I had the chance to experience some of this while I was in Israel earlier this year. One of the sites that we visited had, before you went underground into the archaeological site itself, they had a virtual reality experience that took you through what this site would have looked like when it was active and the Romans were there and walls had paint and walls actually finished being a wall and transitioned into a ceiling. And to be able to sit there, and the group of us were from all different nations, and we got to do this in our own languages. And because the headsets we had allowed us to move our heads around, and the video would react, it had built-in gyroscopes, and it would react to our motions. The museum set us all in spinny chairs, and we're all rotating around and looking up, looking down, and we could decide how mobile we did or didn't want to be. And this kind of an experience, coupled with then getting to go into the archaeological site, really brought it to life in a way that simply seeing ruined buildings never could have.
Yeah, the sky's the limit, I think, in the ways we can use AR and VR to reconstruct the past, to sort of imagine different futures, to create museum exhibits that otherwise could never exist. So we could use VR, AR to, say, juxtapose an item that we have in our collection that's maybe an artifact that has 3 or 4 different Native American languages on it, next to the Rosetta Stone.
Yes.
That it lives in the British Museum and will never leave the British Museum. But the British Museum, to their credit, is on the forefront of digitizing and scanning their collection. And so they make a highly detailed 3D model of the Rosetta Stone available for free for anybody who wants to use it. And that enables us to build sort of cross-cultural experiences that we never could build in any other way. And when you think about it from that perspective, suddenly we have basically a blank canvas to imagine what would be the optimal way to present this information. And we can probably use AR or VR to do it. But it does come with its own challenges of not just virtualizing everything. Because then why have a museum at all? Why wouldn't we just have a big warehouse? So we want VR or AR to be part of the museum experience, but it can't be the entire museum experience, or we've sort of engineered ourselves out of a job. And we probably haven't presented the best possible experience, because there are some things that are always going to be better when done tactile, and there are things that will probably always be better when done virtually. And the challenge and the opportunity is to identify which fall into which camp and how to interleave them in such a way that you feel like you're having a cohesive, engaging experience, even if you're transitioning from one medium to the next multiple times throughout your visit.
And this does bring up the interesting things that you can and can't do with VR. So on one hand, you have the opportunity to take all of the verbiage and all of your exhibits and block them out with a big colored block and replace them with someone's native language. But at the same time, if you have someone who's visually impaired, while you can have that audio track that as they move past various RFIDs, it tells them exactly what it is they're not seeing, they can't, from home, they can hear all of that, but they can't walk up to the exhibits that are so often present and touch a dinosaur bone, touch a space shuttle tile. So you have that ability to address the needs of the visually impaired in the real world museum like never before. And you have the ability to augment things by showing the dinosaur bones with the various levels like never before in the museum. And there's always going to be that one thing missing with our smartphones, no matter how smart and Google Cardboardy they might get.
Yeah, there's always challenges when using the new technology, especially a digital technology, which often can be so sort of monosensory. It's
Yes.
either all audio or all video. But you have to kind of dig through that to find the opportunity, because you're right. For a lot of visually impaired users, something like AR or VR is a big problem. But from a different perspective, it can be a huge opportunity.
Yes.
Because for conservation purposes, there's often the need to keep people, say, a certain distance away from our dinosaur bones. Well, that's not a problem in VR. And so if we can put those dinosaur bones in VR in a way that you can virtually get a millimeter away from them, that's using a medium that might generally be troublesome for somebody with a disability in such a way that you're using it to overcome an obstacle that they have in the existing physical world. That doesn't make it good in all instances, but if you find the right application, sometimes something that seems like it would on the surface be a bad match might reveal itself to actually solve an existing problem that we've had for decades that we really haven't even sort of considered as being a problem so much as a necessity.
And this is where it really comes down to the importance of universal design, which is doing something that is making the content more receivable to people of a variety of different abilities. And by making it natively more accessible, you are also making it better for everyone. So by adding those zoom features, those ability to focus in on a smaller field of view, you're really making it more accessible for people with a variety of different visual impairments, but you're also bringing those details to everyone else. By adding the text to the audio, you're making it more accessible for the hearing impaired, but you're also making it easier for people who learn better when they both see and hear the words. So it sounds like you're using technology in combination with reality to create something that is the best of all worlds. Is that how we put it now?
That's the hope. and it's always a continuum, and it's always in evolution. And I think we, along with most all museums, are very, very early in that process. We're using VR in the museum, but only in pretty simple, sort of straightforward ways that aren't really different than how you could use it at home. But we're using that to sort of understand the operational challenge, which is something that we don't have when we work with VR, AR, say at home, is how do you do this at scale? How do
Yes.
you keep things charged? How do you clean things? And I think we've encountered problems both operationally and in things like equity that we never anticipated just through doing some of these basic experiments. And then behind the scenes, we're envisioning all sorts of other possibilities, and then trying to chart a path from where we are and what we can do now to where we want to be and where we think technology is going in the future. And so everything can seem sort of calm and sort of at best up to date right now, but behind the scenes, under the surface, there's a lot bubbling that we hope will be coming sooner rather than later, if only we can overcome this one thing or that one thing.
It sounds like a truly amazing future is on our way. Now, the one thing that we haven't really discussed that much, which I'd like to end on, is tell us more about the Weekly Space Hangout, and if you can, the origins of the Weekly Space Hangout crew, which is also such a rich part of this particular show.
The Weekly Space Hangout crew are our saviors. I don't think that's overstating it.
No, that's correct.
So the Weekly Space Hangout airs once a week on Wednesdays. I'm trying to do some time zone conversions rapidly in my head. I believe at 8 p.m. Eastern, and it runs roughly September through June.
So 8 p.m. Eastern is 5 p.m. Pacific is 10 a.m. plus 1 day in Sydney.
Well, she's putting me to shame. That's rough. And we stream for an hour live on YouTube. You can also get it as a podcast wherever your favorite podcasting location is. And we usually cover 3 or 4 stories and interview a special guest. And we have just absolutely amazing special guests. And I can say that because I can take literally 0 credit for the appearance of those special guests. We've in this last season, where we've probably interviewed, 30 or 40 special guests, I was responsible for exactly one of them. And who was responsible for the other 39 was the Weekly Space Hangout crew. And I think their website these days is wshcrew.space. These fancy new top-level domains are still weird and mystical to me. And they originally formed basically as a support group for the months that we were off.
Yes, it was Nancy Graziano who basically said, we need some place to keep chatting, and she just got everything going.
And it started, I think, on Google+,
yep,
which instantly will date its origin to a very, very narrow slice of time in which people actually thought, I'm going to start a, I don't even remember what they're called, community on Google+.
Yeah, community.
They have since moved, I think, beyond that to a myriad of media.
Slack being our number one.
But they have sort of transcended their support group status to become, as Fraser likes to say, the executive producers of the show. And they go out and they scour the world for the most exciting and interesting people in the world of space and astronomy. And they bring them to us. And we get to chat with them before the show and interview them for 20 minutes during an episode, and sometimes cajole them into staying for the episode. And they're truly amazing people. We've had astronauts, we've had high-level people from NASA, we've done 2 interviews with Andy Weir, author of The Martian. Uh, we've done so many things that I can't even really disentangle them all, other than just being sort of a pure stream of amazing.
I
And
completely agree.
if they stopped doing what they do, the Weekly Space Hangout would stop existing as a podcast, because all of us have other jobs and couldn't dedicate enough time to make show the quality that it needs to be worth doing.
And
But they so graciously and so amazingly do the hard work of running down people, of setting up time slots, of putting together a spreadsheet so that all we have to do basically is show up with our one little story in hand, and the whole thing just goes off generally without a hitch. And it's a minor miracle each and every week.
It really is. And I just brought up their webpage, and it turns out we're streaming live on their webpage. It's kind of awesome. And so you only have a few more weeks left before you go into hiatus for the season. And in the chat, we're getting reminded that the Weekly Space Hangout crew is actually organizing a 500th episode celebration for Astronomy Cast. And we are truly the old people of podcasting, but on the weekend of September 15th, 16th, we're inviting our entire audience to come out and join us face-to-face here in Edwardsville, Illinois. If you want to find out more or find out how to sign up, follow the link that is in the chat or go over to astronomycast.com and it should be linked. Now,
I just want to say that I think Astronomy Cast is, and I've done, I don't know, a couple of Astronomy Cast episodes over the years, is like the most intimidating thing in all of science communication. I'm not sure that I will do 500 podcast episodes in my life. And I certainly know that I don't know 500 podcasts worth of information. And so how you and Fraser have managed to keep that up long after I think the rest of us would have exhausted either our enthusiasm or our knowledge is just truly extraordinary. And I hope that I can make it out in September to watch you guys do episode 500, because there's nothing else like it out there on the internet. And all of us are just kind of looking like this up at it every time we get online.
Thank you so much. All the emotion. Yeah, we love what we do, and we're lucky enough that the universe keeps doing new things for us to talk about. So as long as there's still people out there doing astronomy, we'll always have new ideas, new topics, new discoveries, new updates. So I guess as long as we have a universe and breath to talk about it, we'll still be bringing you episodes, which is a little bit weird to think about. So do you know who your guest is next week?
See, I don't. I don't usually find out literally until I join the thing and I see who's on our rundown. That would be a valuable thing for me to know going into an interview. But it illustrates the power of the Weekly Space Hangout crew, is I truly have not the faintest idea who our guest is next week, because I just know they're going to be amazing.
That is absolutely amazing. I need to get better at leveraging the Weekly Space Hangout crew. So that concludes our episode. We've been doing this for 1 hour, starting the second time 12 minutes late. Thank you, everyone who came today. We're going to be working to get the learning space going. Every week, we're going to alternate between doing it in the evenings and doing it in the mornings as far as Central Time Zone is concerned. And this will allow people both in Europe and in the Pacific Rim to get to experience us live at least half the time. If you like what you see, give us a follow. It will get you notifications of when new episodes are coming up. Learning Space is actually supported through Patreon. If you go to patreon.com/learningspace, you can find out all about all the things that we have to offer. So please go on over to Learning Space on patreon.com and consider giving us a subscription so that we can keep these episodes going. Now, do you want to tell everyone where on the internet they can find you, Morgan?
Oh man, since I got a real job, I've basically fallen off the face of the internet. But you can check out my website, morganrenberg.com, or at least nominally follow me on Twitter at Morgan Renberg.
And you're available as a speaker, and you are still a researcher, however small an amount of your time you carve out for that. So this has been a fabulous hour, and thank you for helping me repeat the first 12 minutes. You truly are patient as well as communicative. So thank you, everyone. And I'm finding out from the good folks, in this case, Susie Murph, that next week's Weekly Space Hangout guest is Stella Kafka, the director of the American Association of Variable Star Observers. So thank you, everyone, for coming. And thank you, Morgan, for bringing one hell of a good explanation of the sand dunes on Pluto, which I guess we really should be calling methane dunes on Pluto.
Moons?
Methane dunes. Dunes on Pluto. And thank you, audience, for joining us and bringing the chatter. Wherever you are in the world, wait, I forgot to tell you what's coming up next. Tomorrow on this channel at 1 p.m. Eastern, which is 6 p.m. London, which is 10 a.m. Pacific, Dr. Andreas Plazas is going to be bringing you the daily space while I take the morning off. So thank you for joining me tonight. I hope all of you will check out Andreas in the daily space tomorrow. And as always, have a fabulous morning, evening, or afternoon, wherever in the world you may be. And don't forget to look up. Bye-bye.